When scientists have something that they're trying to describe but they can't see it, they have to rely on inferences or indirect observations using things like maybe their senses or instrumentation. And scientists call this a black box problem. In this activity, you're going to use a black box quite literally to try and determine what is going on inside the black box. Now, the mystery here, okay, is not so much what's in the box. Right? Inside each of these boxes is a little metal BB. Okay? The mystery is going to be what is the configuration of the barriers inside that box. So you're going to have to rely on your senses, on indirect observations, on inferences, and to determine exactly what the configuration might be. Now, as you saw, that one was a triangle. Others might have barriers that are not, a full geometric shape, or there might be nothing in there at all. Okay, so you have to think about how you would test these black boxes to determine what the configuration of the barriers inside is. There are 12 different shapes. They are numbered on the bottom, underneath where my finger's at. I'm not going to show those to you, obviously. And the one ground rule for this activity is you cannot open the boxes. Fight the urge. All right, make your best predictions, and maybe at the end of the activity, we'll let you see what's inside. When you get your first black box, you want to look at the number that's on the underside of the box itself, and you will want to record that number up here where it says observer number. So I'm just going to put, just say it's number 6. Okay, and then what you want to do is move that box around, listening for that little ball bearing to move around, and based on what you observe, what your senses pick up, you want to make a hypothesis about what you think the configuration of the barriers is on the inside. And once you've taken, I'd say no more than a minute or so to make those observations, you want to draw your initial hypothesis in the hypothesis circle. Now, the circle itself represents the boundaries of the black box, and so inside what you're going to draw is what you think the configuration would be. So I'm just going to say, suppose I think this is a square, so I would draw a square in the first one. It's a little rough, but you get the picture. And then based on that, I would think, okay, if that were a square, how would I expect that ball bearing to sound as it's rolling along each of those surfaces? And how could I, move the box to test that hypothesis? So then you want to carry out that experimentation. And if you still feel that it's the same shape, then you would just redraw the same shape in your revision circle. But if you change your mind, maybe you've gathered some new evidence and you think it's something different, then you would draw your updated hypothesis in the revision circle. And so let's say, well, maybe I think it's a triangle now instead of a square. So I would draw that in the revision circle. At that point, you're done with that observer. You're not going to do anything with the actual, because remember, the main ground rule here is do not open the box. All right, if you do that, it's 0 for the activity. Okay, at that point, you're then going to get a different observer of a different number and repeat the process in the next area. And then once you're done with that one, you'll get another box of a different number until you have filled out the worksheet. Once you're done, then I'll reveal to you what the shapes are, and you'll come back and you'll fill in the actual area and compare, and hopefully your final hypotheses will be correct.